Hi, everyone, and welcome back to Organic Chemistry in 5 minutes or less. Today, we're going to talk about ether syntheses using alcohols and bases. So the fundamentals of this reaction involve starting with an alcohol. Here's just an example over here. And you use base to activate this alcohol, in other words, to make it a better nucleophile to then react with an electrophile. And the electrophiles are usually an alkyl halide or any type of alkyl group that has a leaving group. So here are the reaction conditions. First, we take an alcohol and react that in the presence of base and a alkyl halide. So here I've left base somewhat ambiguous. You basically need a base that's strong enough to deprotonate an alcohol. Something like sodium hydroxide will suffice. And this makes an ether. So here's the mechanism. So if we take ethanol and we react it with sodium hydroxide, we know that the hydroxide and the sodium will dissociate 100%. And the hydroxide comes in, deprotonates the alcohol, and moves the electrons in the oxygen-hydrogen bond onto the oxygen. This makes ethoxide. And then ethoxide can react with methyl iodide, which is one of the best electrophiles you can have. So it does an SN2 reaction and kicks this right out. This then forms this product. So some things to remember: the base is needed to deprotonate the alcohol. In principle, this reaction could go without the base, but it would be much slower because alcohol is a much worse nucleophile than the alkoxide that results from the deprotonation. So questions you might ask in office hour: 1, what is the mechanism for this reaction without the added base? 2, does the nucleophilic addition step have to be SN2? Could it be SN1, for example? And are there any side reactions that are possible? Well, it's been Organic Chemistry in 5 minutes or less. Thanks for tuning in.